Okay, so we're going to be evaluating this double integral over the region D, which is just the region enclosed by these two curves. Now, I think that the more difficult part for these problems is to determine your limits of integration rather than the actual integration itself, okay? And so here we're going to allow one of our variables to be bounded by constants, and we're going to let the other variable be bounded by the curves themselves. Now, looking at our two curves, notice that we have y given as a function of x for both of them. And I really don't see a reason to switch that up. So you would be welcome to solve for x and get x as a function of y, but there's really no reason to do that. And so I'll say here that just by looking at my curves, I'm going to have x bounded by constants. And I'm going to have y bounded by the curves. Okay, so the easiest way to go ahead and determine these limits of integration would just be to sketch our region D. So that's what I'm going to do. Now, the first thing I'm going to do is find where the two curves intersect each other. This is going to be important because it's really going to give us our limits of integration for x, and it's also just going to give us a good visual of our region D. And so I'm going to find where these two curves intersect. Well, what does that really mean? Well, I'm going to set y equal to y, meaning I want their value to be the same at these points. And so if y is set equal to y, that means I'm setting my two curves equal to each other. I have x squared equal to 3x. Then I'm going to go ahead and solve for x. So I have x squared minus 3x equal to 0. I'm going to pull a 3 here, or sorry, pull an x here. I have x minus 3. And now if the product of these two factors is equal to 0, then that means that either x is 0, or we must have x minus 3 equal to 0. Meaning x is 3. So just go ahead and add that 3 to the other side. Now this is good, but we really want these as an xy coordinate, right? And so what are my points of intersection? Well, one has x value 0 and the other has x value 3. Now, how do I determine my y value? Well, this was the intersection of our two curves. And so I can really use either of the curves to get my y value. It'll come out the same. So we can check to make sure that that's true. If I take the 0 and plug it into my first curve, I get 0 squared is 0. If I take the 0 and plug it into my second curve, I get 3 times 0 is also 0. So good, that makes sense because they're supposed to intersect here. Now I'll do the same thing with the 3. 3 squared is 9, but also 3 times 3 is 9. And so that works out just as we expected. So here are my points where my curves intersect with each other. And now, like I said, this just helps us get a good sketch. So let's go ahead and sketch this. So I have one point at 0, 0, or one point of intersection at 0, 0. And I have the other at 3, 9. So let me count these. That's 9, hopefully. And 1, 2, 3. Okay, so there's my points of intersection. And now I actually want to sketch my curves. So let's just do them in two different colors. So I'll have the green be y equals x squared, and I'll have red be y equals 3x. Now the sketch is going to be important here because remember I said x is just going to be bounded by our constants. So that's going to be pretty easy to figure out. Y is actually bounded by the curves, and so we need to know which one is its lower bound and which one is its upper bound. And so the sketch is going to be important to know which is the top curve and which is the bottom curve. Now, just by looking at the curves, we know that this green one is a parabola, and then the red one is just a straight line. But you still may be a little confused about what that's going to look like. And so here's what I suggest. We see our x values go from starting at 0, and then the furthest one to the right is at 3. So just pick something in the middle and see what happens, and that'll give you a better idea of the shape of the curve. So let me take green, and let's say we have x equal to 1 would be fine. So for the green one, 1 squared is 1, and so we'd have a point at 1, 1. Now for the red, if we plug in 1, we have a point at 1, 3. So I'm immediately seeing actually that the straight line is the upper curve. Now it looks like my drawing isn't going to be great, but I'm going to try my best. So here's my straight line. Ooh, could be straighter, but that's okay. And so that's my y equals 3x. And then I have my parabola in green. This is a little bit squeezed in here, isn't it? There it goes. It's good enough, I think. So I have y equal to x squared. Okay, and this picture should give us all the information we need to get our limits of integration. So what do I have based on this? Oh, can't even write. Based on this picture, let's do x first. So I'm going to let x just be the constant x values that we take on here. So the lowest value is 0, right here. And then the largest x value is here at x equal to 3. Okay. But now something has to depend on the curves, right? I mean, this isn't a rectangular region where all the limits of integration are just constant. Now we actually have curves involved, and we're going to have to let y here depend on the curves. Now you can think of it as a top and bottom curve, or one that has the larger output values or the smaller output values, however you want to think about it. You can even draw in a line here. So here I'm talking about my y values. So if I have this straight line here, what would it make sense to make my lower bound? Well, it looks like x squared. And my upper bound here would be 3x. Okay. All right, now we've kind of done all the work for determining my region D, what it looks like. Maybe I forgot to say, this here is my region D, this enclosed region. Okay, now we're ready to integrate. So let's just move on down here. So we wanted to take the double integral over the region D of x, y, dA. And now we got the information we needed. So one important thing is to always keep the constant values on the outer integral. So this would be 0 to 3. And then have your curves or your functions on the inner integral, which was x squared to 3x. All right. Now, be careful about what order you have, either dx, dy, or dy, dx. So first of all, I like to kind of section off my inner integral because that's what I'm going to solve first. So let's go ahead and do that. And then make sure we label this correctly so we do our integration correctly. Otherwise, we'll be in a world of trouble, right? So here, x squared to 3x were my limits of integration for y. It was my bounds on y. And so this inner integral is dy. So it's my integral with respect to y. And then the outer one was my limits on x. And so I have dx out here. Just make sure you label properly to make sure that the integral actually works out and it works out correctly. Now, the way I like to do things is to go ahead and solve the inner integral. That's what I call it, and then put it back into the outer integral. So that's what I'm going to do. I'm going to just solve this, what I have in the red brackets. So this is I'll call this my inner integral. Now I'm integrating with respect to y. So this x just gets treated as a constant. So it's like a constant coefficient of y. And so I'll just keep my x and go ahead and integrate y. So I get a y squared over 2. And I'm integrating from x squared to 3x. Now, something that I think is helpful is to make sure I say, okay, I was integrating with respect to y. These are my limits of integration for y. So I'm actually plugging these in for y. That means this x here is just going to hang around. We're not messing with it. We're not plugging anything in for it. Right now, that x just stays there. Now I'm going to go ahead and pull the 1/2. Obviously, you don't have to, but I'm gonna go ahead and do that. You know, maybe I'll save that actually. Let's leave the 1/2 for now. It really, it doesn't matter, but just go for it without taking it out. Okay, so I'll start with my upper limit, which is 3x. I'm going to take that and it gets filled in for y. So the x stays here. Then I get a 3x squared over 2. Minus, now I'll do my lower limit. So again, my x just sticks around. Now this y gets replaced with x squared. So I get an x squared squared over 2. Now I think I'll pull the 1/2. I could have done it earlier, but I thought maybe we'd get confused. So we'll pull the 1/2 now. And now let's do a little simplification. So here, when I square the 3x, I get a 9. Then I have x squared with the extra x becomes an x cubed. And then minus, so x squared squared is x to the 4th, and I get an x to the 5th. Okay, looks pretty good. And now remember, this was just my inner integral. I'm gonna put a little bubble around this. Okay, so this is only this inside part that I have in the brackets. And so everything I have in my blue bubble is gonna go right here, okay? So I still have my 0 to 3. Now I need my inner integral that I already evaluated. That was 1/2 9x cubed minus x to the 5th dx. Now we're just integrating like normal. We don't have two variables anymore. We're just integrating with respect to x, and you know that we should be pretty familiar with. So let's go ahead and integrate. So I have a 1/2 that I'm just going to pull. And now let's integrate my 9x cubed would be 9x to the 4th over 4. I'm going to minus x to the 6th over 6 from 0 to 3. Now you're welcome to do the same thing and say this is going to go in for x. I think that's more obvious now, but it is a good thing to practice, especially maybe you're doing, you know, a triple integral and you need to make sure you know what you're actually filling things in for. So it's good practice. Now we can actually pull another 1/2. Oh, do we want to do that? I don't know. Let's leave it out, leave it in for now. So I'll just go ahead and start evaluating. All right, so do my upper limit, which is 3. I have a 9. I have x to the 4th, which is 3 to the 4th, which is 81. Then I have an x to the 6th, which becomes a 3 to the 6th, which is 729 over 6. Minus, now, there's always some simple joys in life, aren't there? One of my simple joys is when one of my limits of integration is 0. I just love that because lots of times this is what happens. I plug in 0, I get 0 over 4. Well, it's just 0. I plug in 0 here. 0 to the 6th is also 0, and so I just get minus 0. That's always nice when it all just disappears. Okay. Now we can do a little bit of simplification. I'm not really sure how much you would be interested in. I don't know that I'll simplify the whole way. To me, it's not crazy important, but some people maybe it is. So 9 times 81 is going to be 729 over 4 minus 729 over 6. Again, we could actually pull a 1/2 again. So if I pull a 1/2, I'll get 1/4 729 over 2 minus 729 over 3. And I don't know, this looks okay to me. So I'm just going to circle it and say, I guess this is my answer. Although now that I'm looking at it, I'm pretty sure you can actually divide 729 divided by 3. But this certainly is the correct answer, even if it isn't simplified fully.